Okay, this is part two, the presentation given on November 27th of the conceptual design report for the Big Sky Water Resource Recovery Facility expansion and upgrade. Ran long, and we ended up skipping the disposal slides and the disposal portion of the presentation. So today I'm coming back to go over those slides, record them, and Ron will add them to the website. So we're going to pick up about where we left off on the 27th of November, which was, as I said, disposal alternatives. We looked at essentially four reuse and or discharge alternatives. Snowmaking was technical memorandum number 11. Indirect subsurface discharge, tech memo number 12. Reclaimed water irrigation, so further development of purple pipe, is tech memo 13. And then direct discharge is spread across two tech memos. 14 is the analysis of disposal, discharge in the river, mixing zones, all that. And then tech memo 15 is the outfall pipeline to get to the river. Tech memo 14 gives a very brief overview of what was done with all of these subsequent reuse and discharge alternatives. So if you just want the short story, you can go to tech memo 10. If you want to dive deeper into any of these alternatives, you would go to their respective technical memorandum. I want to make a note that when we first started the study, we were looking at coming off a wet year where disposal had been down dramatically. There was a lot of pressure, disposal pressure that year when we first started the work. Since then, the Yellowstone Club has made additional irrigation capacity available there towards their ultimate commitment of 160 million gallons. That commitment is shared with Spanish Peaks. So that has taken some of that pressure off that was on the district in 2017. For the next few years, depending on growth rates, there's a little bit of breathing room, so it's not quite as urgent of a solution or timeline. This slide is also, it's in Tech Memo 10, the overview, and it's just showing the alternatives that were given a hard enough look to put a conceptual level cost estimate on it. So I'll just run through these real quick. The snowmaking with reclaimed water, we looked at the Southern Comfort area of Big Sky Resort and disposal there. Now, a lot of the comments were, well, we can do a lot more than 16 million gallons. We don't disagree with that. It's just this was kind of a surrogate case to look at million gallons kind of per acre, or just everybody be able to wrap their head around a given area, in this case Southern Comfort. How much can you dispose of there on average in a typical year? Well, that's 16 million gallons. If Big Sky Resort and Spanish Peaks were to work together to put in more infrastructure, more guns, and cover more area, certainly you could get rid of more, but that's not in the district's control, so we just capped it there. The end result of that is not a great economy of scale, because as I'll show in a bit, you would need multiple pump stations and quite a bit of pipeline just to get to Southern Comfort. So it's $2 million approximately for 16 million gallons of disposal, so not a great trade-off there. Under indirect subsurface discharge, looked at two options. One was return reclaimed water to the Firelight Meadows system for disposal in their existing drain fields. So this would be annexation of Firelight Meadows and just take over that drain field there and operate it at a similar loading rate. That would cost approximately $1 million for the infrastructure to get to that drain field, and would enable disposal of about 10 million gallons annually. The other option with Firelight Meadows would be to, because we would have a much higher quality of effluent with the district's effluent than what the on-site treatment system is doing at Firelight Meadows, we could improve the capacity there. The hydrogeologists stopped at 28 million gallons annually. Further study would be needed to refine that number, but stopped there because additional mounding of water on that site could lead to groundwater taking flow paths that are more direct to surface water versus dispersing sort of parallel to the South Fork. So that study we'll talk about more, and that's a path that would need a further investigation of groundwater hydrogeology there, and if it did prove to be promising and feasible, the estimated cost for the infrastructure to do that would be about $1.6 million, and you could get rid of 28 million gallons annually. Reclaimed water irrigation, Firelight Meadows again kind of proves a good proxy or test case, but looking at just irrigating landscaping and open space there, as long as you were putting in the connections to the district's effluent reuse pipeline, go ahead and tie it to purple pipe and irrigate the landscape and open areas there for $280,000 to get an additional 6 to 8 million gallons of disposal capacity. And as I said, this is kind of a proxy for any irrigation, relatively large irrigation project, which the district continues to consider on case-by-case basis as they come in. There'll be other purple pipe projects in the district's future, I'm sure, that will just kind of be de facto programmatic reuse of, yes, we'll put in purple pipe there and get rid of a little water, but those are all economy of scale decisions that the district will have to make of, well, how much water can I get rid of by doing that? And then lastly, direct discharge of reclaimed water. So in this row, I have shown 185 million gallons, and I need to clarify that. I've showed two different numbers throughout the report. One, this large number in this range, one more of an annual water balance number that would depend on how much additional reuse is developed by the district in the coming years. This larger number of 185 is what I would advise that the district try to permit, not for an annual usage, but for the unforeseen situation where you might have infrastructure failure due to a landslide. You lose the effluent reuse pipeline in a landslide, for example, and lose a very large part of your reuse portfolio. So in that situation, you would need disposal above and beyond what you might need in a typical year where you're just balancing your water balance. And so that's why you see two different numbers used in the report for what we project you might need in 10, 20 years just to get the water balance into balance, versus this what I would go for a permit for, so that if I have a catastrophe of some sort, I do have the legal right to discharge to the river at a higher volume. And that infrastructure, so that includes the pipeline and the outfall on the river, the studies associated with getting to that permit, which are extensive. That's $3.6 to $4 million. I'll come back to that cost in a bit because I want to talk about kind of unit or normalized costs. But for now, this is that hypothetical water balance, and I'll just jump right to the issue I was just discussing, where I'm talking about in a typical year water balance. If the district was able to develop some of that rapid infiltration and irrigation at Firelight Meadows, keep on plowing with the Yellowstone Club and Spanish Peaks, this water balance would need, in this case, up to 70 million gallons going to surface water discharge. So that would be in a year, across a year, 70 million gallons. The plan would be to stay out of the nutrient season entirely, so this could be spread across the winter months, for example, several options there, but that's something that I wish I'd been explicitly clear in the draft. I will be in the final draft of what the difference in the 70 million gallons versus the 185 million gallons. So this would be what I would want to see requested, or suggest to see requested in a permit, but a lower number for average annual need. And to everyone's point, that number can be driven down if other reuse alternatives are developed and grow in capacity. But the district's position is that ultimately we want a surface water discharge permit and that infrastructure for resiliency and redundancy issues in case there's a catastrophic failure up here on the mountain. So spend a couple of slides on each effluent disposal strategy specifically. First would be snowmaking. It comes first in the report at Technical Memorandum number 11. Snowmaking would require a surface water discharge permit. This is per discussions and meetings with DEQ. It's going to require Class A1 effluent, which means that total nitrogen has to be less than 5 milligrams per liter. So that would require an upgrade above and beyond what the district currently has to, for example, an MBR facility that could generate or could get an effluent down to 3 or 4 milligrams per liter to comply with that. So that, just be clear, snowmaking requires at least the phase 1 upgrade that's recommended in the report. One thing we just want to be clear to keep pointing out is that snowmaking is not under the district's direct control. It'd be yet another third-party agreement for disposal. Control of that disposal would not be the district's. If someone decided to shut it off because we were having an exceptional early snow year, for example, those are uncertainties that we just have to deal with. So I think the district's on board with snowmaking. We want to continue down the path of producing an effluent that qualifies for snowmaking, work with DEQ to see them specifically address snowmaking permits, and then it would be up to Spanish Peaks and Big Sky Resort to choose to take that effluent and make snow with it. As long as we're distributing effluent on the slopes for snowmaking in the winter, we could also utilize some of that for irrigation in the summer months. So that again just shows that that 16 million gallons is just kind of a little starter project. That 16 million gallons annual could be grown with some strategies such as just irrigating in the summer, or if Big Sky Resort decided to go a lot more aggressive with the amount of slope area they wanted to cover. This is a map. This is figure 1 from Tech Memo 11, just highlighting those slope areas at Southern Comfort. So the district already has the reuse pipeline passing Spanish Peaks and now connected to this recycled water storage pond as of last year. So we're already getting effluent to this reservoir in Spanish Peaks. It's not seeable here, but you, I think, need 2 lift stations, one to get it over this topography here and into the Southern Comfort Basin, and then another one obviously to lift it up the slopes. And so that's what that and the pipeline is what grows that infrastructure number to up to $2 million. This is an evaluation Jacobs did looking at yearly snowpack for the last approximately 16 years, snowpack at the Lone Mountain Snowtell site, and then overlaying flows from the Middle Fork of the Gallatin River. As Gallatin River Task Force has pointed out, this is their data, and these spikes that you see here, this is middle fork of the Gallatin flow. These spikes are likely due to the interference of ice with the flow metering, so we might remove this from the final draft or just trend it down severely, because these are obviously outliers during winter flows. But so just keep in mind, this is middle fork of the Gallatin River in the black, and then all these numbers behind it are snowpack at the Lone Mountain Snowtel. So as you can see, the snowpack grows over the course of the winter, tends to peak kind of in this March-April time frame, and then declines rapidly. And for the most part, all snow is gone from that snowtel by end of June, which is good for this analysis, because what we're showing is that even at 8,800 feet, snowpack is essentially gone before the nutrient season. So the nutrient season starts in July, and that's when we want to be absolutely done with any runoff of man-made snow, so that we don't impact the impaired middle fork of the West Fork. So this was some good news that showed that that's actually quite feasible to put snow on, in this case Southern Comfort, and have that snowpack gone well before the nutrient season. The engineers and hydrogeologists put together a basic model and looked at if this snow that was applied to Southern Comfort had 5 milligrams per liter of total nitrogen, so that'd be our absolute maximum per Class A1 permit, and melted off in that basin with all the other runoff coming through there in a typical year, then the concentration of that total nitrogen by the time it made it to the middle fork of the West Fork would be 0.04 milligrams per liter. So that's also some good news. That's just with simple dilution, no attenuation of nitrates or anything, which the Yellowstone Club snowmaking study that was done several years back showed there was about, I believe, 50% attenuation of the nitrogen in the snow beyond just dilution. So this indicates that it is feasible to make snow, put it on slopes there at Southern Comfort, and not impact the middle fork of the West Fork. So that's all promising. Switch gears to indirect subsurface discharge. This is Tech Memo number 12. What was done in that Tech Memo was a screening analysis of 4 potential sites. This is land owned by the district just east of the treatment plant site, right on the edge of the West Fork. This is the old driving range at the Meadow Village Golf Course. This is Tract B, or horse pasture, where the district currently irrigates, and then we have Firelight Meadows up here. So these were the 4 preliminary candidates for subsurface discharge alternatives. Firelight, of those 4, Firelight Meadows Subdivision was identified as the best candidate far and away, based on the distance from public supply wells. In this case, that when we're just looking at simple risk, not looking at indirect potable reuse and trying to facilitate that, but actually looking at trying to mitigate the risk of having Class A1 effluent introduced into the district's groundwater. Being distant from public supply wells is a good thing. So that was one of the screening criteria. The other was depth to groundwater. Excuse me. The groundwater around the golf course tends to be maybe 15 feet below the ground surface. You want some separation between any sort of subsurface discharge structure and the highest groundwater elevations. The more distance you have between the two, the better dilution you're going to have, and And so that was one of the screening criteria, and that favors Firelight Meadows, which is based on the limited data we have, maybe 40 feet. Groundwater might be 40 feet below the ground surface, whereas down here in the golf course area it might only be 20 feet. And then on this district parcel it was even less, maybe 10 to 15 feet deep, so that one was eliminated at that point. Other screening factors: hydraulic conductivity and permeability of the zone between the bottom of that infiltration bed and uppermost groundwater. That was pretty good at Firelight Meadows. Probable groundwater flow direction and nearest probable intersection of that groundwater flow with surface water. So that's basically just an inferred connection between where we would discharge to the subsurface and where it would connect with surface water and appear as surface water. And then site history. This is a slam dunk for Firelight Meadows. We know there's a significant nitrogen load occurring there right now that we could either equal with a heck of a lot more disposal, or even reduce with depending on the amount of water that we put there. So, but even with Firelight Meadows, in order to get a discharge permit there, go through and with DEQ and change potentially the amount of disposal that's done there, there's significant additional work required, most of it hydrogeologic studies. Looking at 2 test well installations, doing infiltration tests, pump tests, and site survey to verify which direction groundwater is flowing from that point of application. Do some groundwater and surface water monitoring over 1 year's time to characterize connectivity between that subsurface disposal site and, in this case, the South Fork. It's not clear at all that water discharged at Firelight Meadows is heading to the South Fork. It may be paralleling the South Fork and ending up in the middle fork of the West Fork. So we need to clarify that. That would culminate in a hydrogeologic data summary report, which would serve as the basis of a subsequent non-DEG study. We'd also, as part of the results, have an updated groundwater model. We'd look at the mounding to see if it's possible to put more than 28 million gallons annually there without changing the flow direction of the groundwater significantly. And then look at the nitrogen and phosphorus loading and attenuation. So this is basically that nitrogen fate and transport study we've talked about. Approximate cost for this work would be about $70,000. Potential disposal, if all of that were to check out, would be that we could move up from the 49,050 gallons per day that is permitted there currently to as much as 98,100 gallons per day with that higher quality Class A1 effluent. And potentially during that study with the hydrogeologic model, you could look at disposing of more. The risk at some point is that you're mounting water there and it's going in directions that you didn't predict. So that's where our hydrogeologist stopped, was this is a decent conservative estimate at this time for disposal there. The existing drain fields at the Firelight Meadows property are in the back northwest corner, and then on this north piece here in blue. If we were to go in and expand it, this is just showing where we could add a subsurface discharge structure to increase the amount of disposal capacity. Switching gears now to continued expansion of irrigation or purple pipes. This is covered in Tech Memo 13. We looked at specifically at Firelight Meadows because it served up as another nice test case of how much water we can expect to get rid of per acre. But I just want to reiterate that the district looks at other what we call incidental purple pipe installations as they come up, and that might be in town center or just new developments, and they make those decisions based on economy of scale. How much does the purple pipe cost to put in versus how much can I get rid of? And if it makes sense, I think they'll continue to do that. It's good because it reduces current demand on the groundwater supply. We need that for potable water purposes, and if we can replace irrigation that's using potable water with reuse water, that has a benefit on both the wastewater disposal side but also on the water supply side. So this is just showing the open space in that kind of wheat color. Existing irrigation is shown in green, so that's all water that would be disposed of. We could irrigate both of those. This would be the landscape, and this is just the open space. The open space is not currently irrigated. And finally, Tech Memo 14, direct discharge. So just want to reiterate, the district once had a direct discharge permit to the Gallatin River that was let go in 2003, and I'll show some of the specifics, but that was up to 15 million gallons of disposal across March-June season. So 15 million gallons max in a year, spread across March, April, May, and June. The primary reasons, as I've said, that the district needs a direct discharge permit in Outfall is for backup for infrastructure failures. So if there was a landslide that took out the 7-mile reuse force main between here and the Yellowstone Club, the district's going to lose a huge portion of its reuse portfolio and have nowhere to go with a large portion of their stored water. So that's kind of that failure scenario where almost anyone else in the country has a surface water discharge permit that's not reliant on all that pumping and infrastructure, and so the district needs that as well as a backup for that situation. And so that's that higher flow, that's that kind of 160 million gallon per year kind of number that I would pursue if I were the district with DEQ. I wouldn't need that annually. Not if I keep marching down this path of development of other reuse accounts. I would not need anywhere near that annually, but that's what I would go for to protect against these emergency situations. Just to show what we're talking about here, we're down at the intersection of 64 and 191. This serves as a natural, not just because it's basically a bird's eye path to the river, but because this is somewhat of an impacted area. It's not somewhere where there's a lot of fly fishing and recreational activity, so makes sense to place an outfall along here, and that's the area we focused on. Here's just for reference where the West Fork comes in down here, and we would get some decent mixing from that West Fork, but primarily we're looking at getting our mixing zone in this area here. So this is just some excerpts of that surface water discharge permit that the district used to have that expired in 2003. Here are the outfall, the effluent water quality requirements, so 30 milligrams per liter of BOD, 30 milligrams per liter of TSS, half a milligram per liter of phosphorus, and 5 milligrams per liter of total nitrogen. So these numbers, we would be well below those. If and when this comes to fruition, we'd be well below 30 and 30. We'd also be well below 5 and 0.5. But this was also before DEQ Circular 12 was published by the district with much more stringent requirements for discharge. Basically, we're looking at having to comply with at the end of the mixing zone, the criteria for the Gallatin River, which are 0.32 milligrams per liter total nitrogen and 0.03 milligrams per liter of total phosphorus. This table is just showing the pattern of disposal over those months. So in March, they were able to discharge up to 150 gallons a minute. April 160, May 300, and June 525. So this is just trying to follow a pattern of snow melt and runoff and flows in the Gallatin and basically sneak that effluent under peak flows in the Gallatin. Tech Memo 14 also includes a summary of site conditions on the Gallatin River based on preliminary assessments, review of direct discharge concepts and available chemistry data on the river, also a comparison of current effluent disposal quality from the SBR facility versus the water quality criteria for the Gallatin River, and an assessment of those dilution credits that would be needed to achieve compliance with an MPDS permit. A review of key issues and data needs to proceed with permitting a new discharge. So all this report does at this time is lay it out how the district would need to procure a permit from DEQ. There are studies required, submittals to DEQ. This once you start is a year or two process from actually having a permit in hand. So this is nothing that's going to happen very quickly. There's also a summary of potential benefits of seasonal direct discharge to the Gallatin River. This doesn't pencil out very well, and in essence it's just too little flow in the Gallatin to make much difference. The additional flow from the district might be 1 CFS when flows in the Gallatin are 200 and are on the order of 200 or even 1,000, and so it's just not enough water to make a difference in terms of benefiting low flow periods. And then there's recommendations for continued data collection, especially temperature and dissolved oxygen in the river. We don't have a lot of that data, and that'd be important for determining whether or not we need to cool the effluent before we discharge it, and whether or not we need to add any additional dissolved oxygen to the effluent so we don't have any kind of sag and DO near the outfall. The goals of this preliminary study for direct discharge were to identify a good site with good discharge mixing in a defined reach, comply with Montana's numeric water quality standards that are outlined in DEQ 7, ultimately design a discharge to maintain river morphology and aesthetic quality of the site. We did some preliminary conceptual type designs just to show what we would be thinking that would meet this criteria, that it's not going to stick out like a sore thumb down there. And then that outfall, as we all know, would have to be resilient to ice flows, which can be significant here and tear away an outfall if it's sticking out in the middle of the river, so that was important, as well as floods. And then select a site and a design that would protect aquatic habitat and stream use. The screening evaluation of potential direct discharge to the main stem Gallatin shows that the river flows provide enough dilution credits necessary for a discharge of the existing treatment plant. This is the SBR plant that the district owns and operates right now. That effluent could potentially comply with surface water discharge standards right now in the non-nutrient season. There are a couple of hits in the priority pollutant data that's been taken on the existing effluent. It's some organic carbons that would need to be removed, but all this is saying is that the current regs in theory would allow for the current district effluent to be discharged to the Gallatin River with dilution credits. That is not the plan. Phase 1 if it is moved forward, is expansion and upgrade of the existing facility to a membrane bioreactor facility that's going to generate a much higher quality effluent. This is just to show that it's possible now. It'll certainly be feasible with a much improved treatment plant. Meeting Montana's numeric water quality standards and non-deg criteria for non-significant changes in surface waters is feasible. So again, we'd avoid any discharges during the nutrient season, which is July 1st through September 30th for the Middle Rockies ecoregion level 3. Based on spreading that flow across the winter months, effluent flows could be less than 2% of the river flow even under the lowest flow conditions of 7Q10, and less than 0.4% for average daily flows in the river during that discharge period. So we're thinking November, December, January, February, March kind of time frames. So this would attain less than 15% of the lowest applicable standard at the end of the mixing zone if we did this. And this is what complies with the non-deg criteria for non-significant changes in surface waters. Again, we would not be discharging during that late summer, early fall nutrient season. Effluent could be metered, meaning just it's going to be stored here as usual, and what is discharged into the river could be a steady rate over days. Could vary. We could make it vary with river flows. There's a number of options there. Regardless, there's extensive study remaining to be done in support of a permit application. A lot more data collection of effluents and ambient river quality analyses and documents, reports that would summarize that data. There's permitting requirements and hurdles and meetings we'd have to have with DEQ, and then we would also, once the district would decide to take this on or not, there's also a public perception and acceptance and education that would occur. And so my point again is that district is not currently pursuing this. It's going to be a 1 to 2 year hurdle once they push the go button. So it's nothing that's going to happen fast, and everyone will have an opportunity for input. Direct discharge. This is showing measured Gallatin River flow at the USGS gateway gauge and calculated Gallatin River flow above the confluence with the West Fork of the Gallatin River. So there's no USGS or anybody else monitoring flows in the Gallatin River upstream of the West Fork, so upstream of Big Sky. So that's unfortunate. That's been the case for decades, and so Montana DEQ developed a correlation between flows at the gateway gauge and flows above the confluence with the West Fork. Basically credits 71.6% of the flow at the Gallatin gateway gauge as the daily flow in the Gallatin River above the confluence with the West Fork of the Gallatin. So it picks up about another 30% of its flow between Big Sky and the Gallatin gateway gauge. So Gallatin River gateway gauge is in orange here, and then the direct correlation of flows made in Gallatin above the West Fork is in blue. So you can see that based on this estimate, winter flows tend to bottom out, say around 200 CFS, and then it starts climbing in April, May, and typically peaks somewhere around early June at maybe 2400 CFS, and then tapers off and back down to that low flow winter period of approximately 200 CFS. This would be the nutrient season outlined here, July through September. Average daily flow in the Gallatin River above the West Fork, October through June, so fall through early summer, 555 CFS. From November to May, so honing in a little bit more on that winter season, 405 CFS. This is just a shot of looking downstream at, here's the bridge where the West Fork comes in. This is the intersection of 64 and 191 here. DEQ now basically does their own lowest flow in a 7-day period with a 10-year recurrence interval, what we call the 7Q10. DEQ now makes those calculations themselves and wants to give them to the engineering firms. So we sent this location to DEQ, and their response was 129.3 CFS. And that's based on the drainage area ratio from the Gallatin River gauge. So they're doing an estimate based on the runoff basin, surface area of the basin, and getting 129.3 CFS, which you can see would be, in our opinion, extremely conservative based on this correlation equation between Gallatin Gateway flows and upstream of the West Fork. So we took that. We used this value. My only point here being, I think there's a definite another layer of conservancy there. And then shifting gears to what this actually might look like. So 191 running here, an outfall pipe coming under the highway 191 and discharging into the west side of the Gallatin River, and then we would have protect it with boulders basically from ice flows and try to keep it in place over the course of those ice flows. This would be a buried pipe. You would not see it standing above shore here. This is just a section cut of what that would look like. This is what we call a duckbill check valve. This helps put some resistance on there and kind of create a jet velocity across here for the discharge, so we get further out into the river and get more dilution. So after kind of giving an overview of what each scenario looked at, and I now want to be very careful with this slide, but this is an answer to questions of, well, which is the lowest hanging fruit in terms of the cost of the projects and how much we could dispose of. And just want to caveat that there's a lot going on behind these numbers. Don't take these numbers and run with them as scripture, but for example, snowmaking with reclaimed water, like I said, the scenario we looked at the direction of the district, and that was with input from Big Sky Resort, and was pretty small scale, Southern Comfort, 16 million gallons, and a fairly costly project because it is kind of the starter project with 2 pump stations and lots of pipeline. Had the highest cost at 13 cents a gallon for disposal. That cost comes down a bit with indirect subsurface discharge at Firelight Meadows. If you did nothing to the existing rapid infiltration beds there, this cost that's almost $1 million is basically to tap into the district's existing reclaimed pipeline, high pressure pipeline, stepping down pressure, likely putting in a bladder tank there, and then running pipe over to the infiltration beds. That calcs out to about 10 cents a gallon. If you were to expand the infiltration beds to dispose of what at this point would be the maximum we'd be comfortable speculating could be discharged there of 28 million gallons annually, it's additional money for that work to be done, but overall, because of economy of scale, you're bringing the price of disposal down to about 6 cents a gallon. Reclaimed water irrigation tends to have a pretty decent economy of scale when you're able to get rid of a fair amount of water like you could at Firelight Meadows. Lots of open space there, lots of landscaping, not a lot of infrastructure required to put that in, so this would be what I would call kind of a slam dunk purple pipe project, as opposed to, say, somewhere in the town center where you might only get rid of 500,000 gallons annually, and it requires a lot of purple pipe retrofit off the district's reclaim pipeline or something of that nature. And then lastly, direct discharge of reclaimed water. Although I'm showing what the district might pursue from a permit perspective to cover emergency scenarios, I'm doing this back of the envelope cost efficiency at 70 million gallons. So this is more like what would make a water balance at build out balance. It would be 70 million gallons of disposal to the Gallatin River at that $3.6 to $4 million total infrastructure project cost. That's 6 cents to 14 cents per gallon, and so I'm covering a couple of different ranges there, low flow, high flow. I'm just showing a large bracket because there's a lot of uncertainty here, but it's certainly right in there with the rest of the others. For what it's worth, that's kind of where these fall out in terms of economics. There's a lot more obviously going on than just economics with these in terms of permitting, and so that's not meant to be the end of the story by any means. And some of the comments received on the report, specifically from the Gallatin River Task Force, were perhaps to try to account for the benefits some of these have on hydrology up in Big Sky. Also discussed with the district, maybe showing the benefits some of these have in terms of water rights. So the final draft will have kind of a matrices of pros and cons, or what we call a Kepner-Trigo analysis that would capture some of those non-monetary factors and rehash this a bit. At this time, the district is not proceeding directly towards any of these. Phase 1 construction of an expansion and upgrade to the existing SBR system is on the horizon, but disposal alternatives will continue to be considered. This slide we did cover on the 27th. These are just some rough approximations of other projects that the district will eventually need to tackle. This is just to kind of show a layout of what if really rapid growth did continue up here in Big Sky. All this is doing is showing that there's a lot more going on than phase 1. So everyone needs to keep in mind the cost of doing business up here for the district in terms of wastewater treatment, solids, side of the coin, and disposal. There are a lot of projects that need to be budgeted for, and so just be aware of that the cost of wastewater treatment and disposal is quite high. That covers what was not covered in the November 27th presentation. If anybody has any questions or comments, they can continue to submit those to the district, and they will be addressed in some form eventually. So thank you for your time.